So it's great to be here. My name is Ali Kheyrollahi. To be honest, to be part of the first Voxxed Days conference in Greece, it gives me a lot of pleasure. Now, this talk, as you know, is about microservices, and it has a lot of similarity with talk that Yanis just before me presented. So I will be, in some of the patterns I will be talking about, I will be repeating pretty much what Yanis said, but you will get kind of a different context from it. So, as I said, this talk is about microservices. We will talk about what microservice is and why you should do microservices, and where it helps you. But even if you are not doing microservices, these patterns are going to help you to basically build more reliable systems. So a little bit about me. I'm a solution architect working for ASOS. My main expertise and the area I work is the recommendations platform, and this is where we use a lot of data science and machine learning. And also I've built the main login monitoring and alerting platform for ASOS. And on one of the systems actually I built, apart from login monitoring system, was a service that was supposed to handle 10,000 requests per second. So as you can see, we deal with a lot of customer requests, and hence, this is an area that we focus on. ASOS is a global fashion retailer. As you can see, it's established in 2000. It's grown year on year, and it handles more load than Stack Overflow, which probably you're familiar with. And we turn over 1.5 billion pounds. Now, obviously, it's not as much worth as before Brexit, but obviously, as you can see, it still is worth something. So, in terms of numbers, I just want to give you a kind of feel for the systems that we build. We got 12 million active customers, and we have a big churn of products. So every week we got 4,000 new products coming in, and this brings its challenges to the business. And in terms of unique visits we have, as well as like number of page visits in a day, as you can see, 95 million. But the interesting point I would like to emphasize is the number of teams that work, and that is why it's actually directly related to our topic. So microservices create a lot of buzz in the industry, and people want to replicate the success of the companies such as Uber, Netflix. Now, in addition to this buzz, there is a level of skepticism and even sometimes sarcasm. People think that, okay, this is SOA all over again. We've seen it, we've done it. And also people think that this is not architecture, this is marketecture. This is just marketing, kind of mixed with architecture. And another thing that people say is that, this is all done to promote consulting companies to make work for them for the next 5 to 10 years. Now, I don't know where you stand with this, but the companies adopted microservices not because they wanted to, because they needed to. The kind of problems they are trying to solve is not possible to solve with any other pattern other than microservices. So, I don't know if you are familiar with microservices. It's basically the reverse Conway law. So what you do, you break up your system into many small components. You build two pizza teams. This is from Amazon. Basically, they said, the team should be as large as 2 pizza, kind of filling everyone. But this is American pizzas, as you know. So you're talking about like 6-7 people. And then getting them to manage 1 or 2 or multiple microservices. And these talk over RPC normally, or REST. So why should you care about microservices? I mean, the first reason, I mean, this is one of the questions from the audience in the last session. Do I need microservices? This is designed to scale the people, not the solution. So what this means is that if you have, I mean, we in ASOS have got 700 tech people. This 700 tech people with 40 different teams working, if you want to get them to deploy every 2 weeks to production, there is no other way to manage that. And another one is basically, it's about decentralizing the decision centers. Instead of having reams and reams of meetings, just enabling your developers to build new functionality and deploy it to production. Another one is reducing the complexity. We've seen it with monolith, how difficult it is to change. But with microservices, you can basically build new microservices, you can change microservices, you can completely rewrite. And even more important, you can actually decommission. Another one is that, obviously, your overall solution is going to be more complex, as this has been discussed before. But there are going to be tools and techniques that's going to help you to overcome that. So, I talked about decommissioning new services. Remember, this is very important. You can actually measure the success of your microservice implementations based on number of services you decommission. It just allows how agile and how decoupled your system is. Because you know it, building new systems is actually very easy. Decommissioning them and understanding all the points that point to that service is very difficult. So a question comes up all over again that, okay, I know SOA, I've learned SOA, and we've been doing that. So what is the difference really? So I've tried to put that in a slide. And as you can see, SOA was mainly an architectural pattern. Its audience was architecture, and it was going to be building around the existing kind of sections of departments of your company. And normally you will end up with dozens, but perhaps a dozen of services. Microservices, on the other hand, is going to completely change your organization. Its audience is actually business. You are telling business, you asked for this feature, I'm going to, instead of 6 months, I'm going to give it to you in 2 months. And they like it because it's very important in an business environment where competition is very high. I worked for a company a few years back, EasyJet, and it was in the process of going to microservices, but actually, it was very difficult to do that. It came to a point where changing a button required 5 weeks of testing. And this is kind of environment that you end up in monolith. So, but it's not all good, is it? Obviously, there are challenges. One of the challenges is the mind shift for the whole of your business. So whole business needs to adopt this. And this means that your developer are going to be doing support. They're going to be responsible for your infrastructure. So they will have the password to production. And they're going to be woken up. And this also means that perhaps you have to let some of your staff go. I mean, the infrastructure teams, the support teams, if all developers are responsible for that, you might have to do that change. Another one is that it's very difficult to actually understand the whole picture, build a picture that kind of encompasses the whole of your system. So, and means that really there won't be many people that know the system, all over the system. And if they do, it will be very high level. When things go wrong, you actually need to know where it went wrong before even knowing why it went wrong. And this gets really, really important because if you have 40 different teams, there is an error in production, you want to find out which team I need to go. Now, if you have lots of different services talking, you have basically removed the boundary, which was mainly in-process calls, into I/O. What do you end up with? More latency. So you have to work very, very hard in order to bring that down. And the last one, this one is a killer, performance outliers. And I'm going to just slightly talk about it. So this is the probability distribution of response time. And probability distribution, as you can see, most of the responses finish within, let's say, like 500 milliseconds. But that long tail that you see is those responses that finish very, very late. And if you have microservices, that problem is going to be much worse. Why? Let's have a look at this case. Let's say 99th percentile. By the way, never ever use averages, obviously, for your response time. Always you need to go back to percentiles. Let's say you have two microservices. One of them has a 99th percentile of 500 milliseconds. The other one also 500 milliseconds. Right? If they were used to talk to each other in process, there would be no I/O. So it would be 500 millisecond, 90th percentile. Now, if you multiply these probability distributions, this is what you end up with. So your 99th percentile suddenly turns into your 98th percentile. If you have 10 microservices, that will turn into 90th percentile. So you see that problem gets worse. And the other thing is that all these actually start piling up in terms of the total response time. So I hope I've given you kind of a bit summary into the microservices. Now we're going to talk about the patterns. So the first pattern is the activity ID propagation. So all of these patterns basically are interrelated. I have to kind of point to the other one when I'm talking to one. But basically, I love this picture. This is a microservice. This highlights the problem with microservice. All these different requests flying around, and you don't know what's happening. You can't correlate one to the other. So what is the solution? Basically, think about it. Every customer request basically matters. You care about every request. And because every request is a business for you, is actually money coming into your business. Every request is unique, although you might not think about it, but it actually is unique. And it results in a chain of calls within your system, and sometimes events. And these are correlated. And this is something that you want to capture. That's why you want to identify these that are correlated. So how do you do that? The solution is actually very simple. So what you do, you assign an ID. So this request, you just assign an ID to it, and this ID can be, UUID or GUID. It's a 128-bit integer. That's great, but some frameworks use 64-bit integers. That's, again, completely fine. And what you do is that you just push that into your local thread storage and make it flow across your code. So wherever you log something, there is error happens, you will find out. And the other thing is that whenever you call the other APIs, right, you include it. Or sometimes you raise events. You also include that. Now, if you want to implement it in HTTP, it's very simple. As I said, it's just not rocket science. A request comes in, you just get the client to send this unique ID. And in the response, you just return that. But just bear in mind, it's optional to send the activity ID. And if it's not there, You just need to create it, return it back to the customer. Why? Because they could actually use that and put it in the log. Maybe there was an error happened, and you want to find out later what happened, right? That was the first one. So the second one is the retry and timeout. This one is a bit more involved. So now let's go to our familiar picture. You got microservice A, microservice B. Let's imagine the likelihood of failure for this request, and this could be I/O, various different reasons, is 1%. And for microservice B is 1%. And let's imagine there are 8 microservices on the other side. What would be the likelihood of failure? It actually comes down to 9.6%. So you are not going to survive without actually retry. So that's why when a request comes in, you basically, if it fails, you have to retry. Now, you don't retry immediately because the likelihood of failure actually is high. So you normally have a back-off period and you add an amount of random element to it, and then you try again. What if it fails again? Normally what you do is that back off and then a bit longer, kind of waiting, and then try again. Obviously you won't carry on doing this forever, but this is another pattern that we're going to talk about. So it's all well and good if it fails. You will know, okay, all right, my call failed, so I know what to do with it. What if it actually times out? That's much worse. That's why you have to build preemptive timeouts. So when you make a call, you basically have a short timeout. If that timeout gets exhausted, you can retry it, but this time with maybe a bit more amount of timeout. Right? And until you finally succeed. So, a question. I have a cascade of these services. What should my timeouts look like in this scenario? Because the problem is, maybe I'm just keep retrying it and C is going to return a result. But A already timed out. What you've done, you've wasted the resource, and you have wasted basically a lot of these threads that could have been serving other requests. So what you should do, you need to make sure that on your edge, the timeout is higher. But that's not all. You actually need to make sure that it's higher than the sum of all of them. And this includes the timeouts as well. So if you are doing retry, make sure that that retry is being calculated. This is something that basically is advocated by John Cockcroft. There is actually another pattern, budgeted. So what they are doing is that they have a budget. They say this request has a budget of, let's say, 500 milliseconds, and they pass it along. And if they get to that, finish the budget, what they do is just abandon it. It's not worth it. No one is listening over it, just to save the resources. So, how do you choose the timeout? It's not very difficult. Microservices basically they have SLO, or service level objectives. And if it's to a third party, you say SLA, service level agreement. Usually between teams, there is no agreement, it's just objectives. So you say, okay, I'm going to choose 95th percentile of my SLO. Now, a better way is that you say, I'm going to start with that SLO, 95th percentile, and I'm going to monitor it. And perhaps based on, if systems are doing better or doing worse, I'm going to actually change my timeouts. So we covered the second one as well. Now, third one, IO monitor. Now, this is another one, blame game. You know, it probably looks completely wrong to say, you know, blame game is good. But think about it. There is absolutely no one that knows whole of your system. So in order to maintain your mean time to recover, which means that let's say there is a failure happening and your company says my mean time recovery is half an hour. So it means that that failure will be avoided. In order to sort it out, you need to first find out what team it is, because no one knows all of the system. So now, in order to do that, you need to measure, because sometimes systems fail and sometimes systems time out. They are very slow. So you have to measure. So every time you go out of process and go to an API, a database, SQL or NoSQL, or even sometimes caches if it's something that you expect, you know, to go wrong, and they do go wrong even if they are Redis. You basically, what you do, you just monitor. Now, there are two things about this that are very important. One is recording it, the other one is publishing it, right? So, in terms of recording it, obviously most people here are Java, and I don't know what framework you're using, but one of them is SP4J, which basically you just call explicitly say, record this. Basically, you say, okay, stopwatch, I started, I measure, and then say record. Another one is you just pass a closure or a lambda expression. And this one is from Perfit in .NET, which is the library I've created, which basically, it's very simple. You say, this closure, run this, and measure it. And sometimes you do it aspect-oriented. So you just declare how it needs to be captured. So what about publishing? You can publish to a local file and let, another system to basically start reading it. That's not so great. Usually people use TCP and HTTP. So if you're talking to Zipkin or InfluxDB, this is what you would use. The good news is that, point to point, you can actually avoid and just use UDP. StatsD and CollectD, both of them can do that. And you could basically push into Graphite or Logstash. If you are running on Windows, obviously there is Windows event tracing Windows, which is very lightweight event tracing. And you can basically publish those kind of metrics. And another one is obviously local communication. You might be just kind of locally use the communication, maybe name pipes or something like that. So the next one, circuit breaker. This is something that Yanis also talked about, and so circuit breaker was around, but mainly was formalized by Michael Nygaard in his excellent book, Release It. So he explained about lots of different patterns. We are just covering some of it here. And the gist of it is very simple. If a system is ailing, having difficulty to respond, just don't put more pressure on it, because it actually is going to make it worse, and it won't be able to come back and recover. Right? So another helpful idea about this is it helps you to prevent from chain reaction on different failures in other systems. So, for example, if one of the services that, let's say you have two different regions and one of the regions is failing, you don't want the other region to fail. So, I mean, this is again something Yanis talked about, Hystrix. So that's one of the most popular implementations. But all of them, it has a closed traffic, closed state, which is basically everything goes in, has an open, which means that no traffic can go through, and there is the other one which is half open, which means that we are just testing the water if we can be successful. So if it is closed, if we detect failure, we open it, then we have some wait timeout, and then which becomes half open, that we try. Now, either we go back to closed, or this is a failure, so we go back to open. Now, all these implementations share that pattern, but what is different is the implementation and some of the parameters, because your definition of what is a success, what is a failure, and how long you should wait, and all of these actually parameters. So this one is the parameters for Hystrix. The implementation is that what they do is that they have a rolling bucket of 10 seconds, 10 buckets by default. And what they do is that they basically, when they have 11th comes in, you just get rid of the first one, and they just measure the amount of failures. And by default, they have 50%, but this is something you could change. Now, it's all well and good to, not go to the other service, but what should you do? Reality is you have to have a fallback mechanism. And the fallback mechanism, there could be different ways of fallback. So one of them is that custom, is probably most popular. Means that you're going to be doing something for the customer to keep basically the clock ticking and keep the business ticking. This could be using a local cache. You could be going to a fallback service, perhaps. Let's say that you have basically two different services. One of them provides real-time recommendations. The other one provides the kind of historic recommendations. You go to one and it fails, you just go to the other one, right? The other one is to return nothing, null, or empty requests. And this is useful for optional services. So if your service is not very critical, so it can simply return no result. For example, again, for recommendations case, you could say, okay, return empty result for the customer. And if it is very critical and very important, that service they can't live without, then you just simply fail fast. So, Canary. This is the least. Last but not least. So, logging monitoring systems should tell you how long your system, basically, should tell you the status of your system. Is that correct? Like if it is working or not. That is, I think, most of the cases correct, but that's not enough, because what if there is no load in the system? So let's imagine a system that wakes up every 24 hours, but you don't want, when it wakes up, to actually fail. You want to make sure that this is the status of that system is healthy. The other one is that, perhaps customers, there is a network problem. The customer can't get to your system. So yes, your system is up and running, but from the customer, maybe there is some networking issue, and you want to find out. And the other one is Again, Yanis talked about this. So your load balancers or a lot of systems basically would need a probe, health probe, so that they could fail over if it's not working. So you have to implement that, right? So health endpoint, we talk about two mainly here. So this two implementation, they exist for health endpoint. One of them is ping, which is a very simple service. All it does, it returns 200. And the other one is Canary. Canary actually will give you a bit more information. And this information is will tell you a little bit more, which we'll go through, but none of that actually calls any of the application code. So it's very tempting for us to go and say, okay, sorry. It's very tempting for us to go and say, I want to make sure that customer can get their orders, list of their orders. So you create a dummy customer, and then say, okay, this my service is going to call this dummy customer. And they say, okay, what about like creating orders, right? So I'm going to go on. This is going to go and create empty orders. And then what you do, you start, okay, what about the amount that it creates? I need to go to finance team and remove the dummy ones. And it just basically, I blogged about it. This is just a slippery slope. So don't do it. Just look at the infrastructure of your system and only report those elements. So as I said, ping is very simple. This could be a TCP or HTTP. And what you do is that you just call the service and you return 200. If something is really horribly wrong on your system, then obviously return 500. But again, it doesn't cause any logic. It just maybe internally within your system something is broken. Now, with Canary, you got little bit more flexibility. But what is it that actually you return? So you return a nested structure. And we're going to look at what you can return. So this is an example of it. So you say, okay, this is my service name, and here is the latency, and the status is like 200, which is correct, or 500 is not. And now we're going to get to is critical. Now, you could actually return a nested result. What it means is that you could basically, this will look at each dependency that it has and then return a status for all of them. But normally what you do, you don't again call any application code. What you do, for example, if it is a database, you just may make a simple connection with your connection string, make sure it's there and report the latency that you've incurred. If it is a cache, if it is a Redis, you just open connection, go back and say, okay, it's good. Now, what about critical and non-critical? In reality, some of your services will be able to work without some of their dependencies, and for some of the other ones, they can't. So you just mark them as critical and non-critical. And in this case, if request comes in, and the critical one returns 500, basically your API, Canary API, is going to return 500. In this case, if the non-critical one returns 500, you still report that 500, that you could do something about it, but the status of your service is still 200. So we have actually in ASOS, and this is something we are going to open source, we have implemented this as aspect-oriented. As you can see, this is C# code, and you can see that you have, for example, we have Azure Storage Canary. All it does, it goes and connect. SQL Canary, I just explained as well, and Canary Endpoint Canary. So this is very inception. So basically, you call your Canary calls Canary endpoint of another dependent API. and it can go from there to the other services. So this is the deep version of that. So as you can see, it calls the API, and that API actually calls the downstream APIs. And if it is shallow, it won't do that. It only goes at that level. Obviously, if you have very deep nested structure, that you don't want to do deep, because maybe actually your request is going to time out by the time that it comes back. And you just pass this flag to the Canary so it knows whether to call the other canaries or not. So this was the 5 patterns out of many patterns that you could use. But just in order to wrap up, I would like to highlight some of the things that we talked about. I know that when you go home, it's very likely that you won't remember kind of a lot of the content here, by the way, which I will put online. But you will remember some of it. And I would like this to be these kind of some. So if you are not having more than 5 teams, and now this 5 is debatable, probably is not, microservices probably is not for you. Now, this doesn't always hold true. If you have a very complex system, and which you need to break down, and your business expects, frequent releases, you still can do microservices. If you are not having login monitoring alerting system, just forget it. I mean, reality is this is the first thing you're going to build, not microservices. First, you start with your login monitoring system. Now, in terms of the pattern we talked about, consider Zipkin. It's very, very good. It actually contains some of the patterns we already discussed, such as the IO monitor. You could easily do with using Zipkin, and it also has got activity ID already built in. Cloud is a jungle. I don't know how many of you guys push stuff to cloud, but reality is that it's like a jungle. At night, you just come out and there are all these different voices and sounds, coming around you. And then you come out in the morning, it's all fine and glory and sunshine and everything else. Reality, things really fail, and a lot of times you might actually not be able to find out why, because it's noisy neighbor, it's all different kind of infrastructure of your vendor and everything else. So you have to cover yourself against it. And without retry and timeout, you won't survive. Every time you go out of your process boundary, measure. Every time. Also, protect your systems with circuit breaker. Hystrix, another thing that I didn't talk about is provides isolation, and that's bulkhead pattern, which I really didn't have time to include, but really look into using Hystrix. And Canary, again, definitely for your microservice, you need to build definitely a ping health endpoint, but ideally a Canary. And with that, I would like to conclude. Thank you very much for your time.
Thank you very much. We will take 1 or 2 questions here.
Thank you. With the Canary pattern, you mean that on every request you have, you hit all the services that you have in line to get health status, or in specific points of time, say every 5 seconds or something like that, you do a scan for the health of the system?
Yeah, thank you for a really good question. I didn't quite mention how you would use it. Yes, so a lot of companies, they have got their site monitoring. So the site monitoring basically goes and like hit some of the endpoints like pages. So this is something that companies use, but for your APIs, this is something you're going to build, which exactly as you said, you just keep every minute perhaps, you keep, this is proactive monitoring. You go and call, and now whether you're going to go deep or just keep calling every API in a shallow way, and then you just build that, get all of that data to your dashboard. Absolutely.
That reminds something from the routers world, the protocol of IGP.
Right. Well, I mean, you could always, exactly. I mean, these becomes protocol level, but this is very much application level of exactly the same pattern.
Thank you very much.
Thank you.
Thank you very much.
Thank you.
There is one more. Okay, of course.
Can I ask you, for example, how can you enforce that constraints, for example, for the times for timeout and retry when you build arbitrary systems, microservices, for example?
Sure. So the question basically is, how do I enforce all these kind of timeouts? I mean, the way that you would do it is, again, there are libraries that help you do this. And what you do is that you would, I can explain to you how I would do it in C#. Basically, I'll pass a Lambda expression to a piece of code which takes a cancel token of the and has a timeout of my kind of choice. And then if it doesn't work, then basically what happens, that cancel timeout will be triggered, and that will inside the code cancel it. And you basically go back with cancellation token resulting in, okay, this was canceled. You would know that timeout passed. So I wouldn't exactly know how would you do it in Java, but I'm sure that there are libraries to do that. I can check out for you after this. Yeah, absolutely. This goes into your application code. Yeah, this is not an infrastructure concern. This goes into your application. But you could use, for example, aspect-oriented, ways of implementing this, so that the developers don't have to just keep being considered with that. So they just have a library and they consume and they provide this their Lambda expression, say, okay, call this with this timeout. And that does it.
So thank you very, very much.
Thank you.
Thank you very much.
Thank you very much. Bye.